A volcanically active Mars suggests its interior may still be warm. If it is, why did the planet's magnetic field die? InSight probes deep into the interior of the red planet using vibrations from small Marsquakes.
InSight uses these to kind of construct what the interior of Mars was like, because these waves bounce off different layers inside the interior of Mars in different ways.
InSight's seismometer builds a picture of Mars by completely redrawing the map of the interior of the planet.
It turns out the crust is thinner than we thought. It's only 12 to 23 miles thick. So there's this whole picture of Mars that is unfolding in front of us that is vastly different than we ever predicted.
InSight's new and improved layout of Mars reveals a 969-mile deep mantle surrounding a metal-rich core.
New analysis of data from InSight reveals the size of the core of Mars, and we haven't had this before. It's so exciting. It's about 1,100 miles in radius. This is a little more than half the radius of the body, which is pretty big and is much bigger than we expected for the size of the core of Mars.
Mars's larger core makes up about a quarter of the planet's mass, and InSight's journey to the center of Mars reveals another surprise.
We have always thought that the core of Mars was long since solidified and wasn't warm at all. And InSight is now showing us that actually part of the core is probably still molten, which is shocking.
There's a liquid core at Mars. I mean, this is crazy.
Data from past missions may help explain why Mars's core is still liquid. Scientists discovered high levels of sulfur in the crust.
Mars seems to have a bit more sulfur, at least in the surface, than Earth does. If we extend that composition to the core and add more sulfur to the iron-nickel core, that would actually reduce its melting temperature, making it possible for this core to be molten today.
We thought that Mars lost its magnetic field when the core cooled and solidified. A molten core changes everything.
Well, how can we explain this lack of a magnetic field at Mars, even though there's a liquid core? Well, in order to have a magnetic field, you need the fluid to be moving and rotating and convecting.
Over time, as Mars lost heat and cooled down, its core stayed molten, thanks to the sulfur. But with less heat, there was not enough energy to power the churning convection of liquid metal that creates an electric current.
The convection in that core would have slowed down to the point where no magnetic field would be generated.
3.7 billion years ago, Mars's magnetic shield dies. The solar wind's relentless attack strips the planet of its atmosphere. As the atmosphere disappears, water on the surface gradually boils away. Since the first probe visited Mars in 1971, 16 missions have investigated the red planet from orbit, while 10 landers have explored the surface. They've revealed Mars may still be an active planet, one that once had the right conditions for life.
Mars used to be thought of as this dry, arid, inhospitable environment. And thanks to the recent Mars missions, we know now that it could have sustained life.
Could there be any ancient Martian water left hidden inside the planet today? MAVEN investigates by analyzing Mars's atmosphere for one of water's components, hydrogen.
The MAVEN mission is looking at hydrogen that's currently in the Mars atmosphere. This is a really important thing to study.
The gas is produced when the solar wind slams into Mars's thin atmosphere and smashes apart molecules of water into hydrogen and oxygen. Hydrogen molecules come in two forms: light, regular hydrogen, and the heavier deuterium. The ratio of the different types tells us about the history of water on the red planet.
It turns out that it's much easier to lose the lighter version because gravity just can't hold on to something that's light as easily as a heavier thing. So we expect that as time goes on, we'll have less and less light hydrogen and more heavy hydrogen.
So if we can measure the outflow of hydrogen from the Martian atmosphere today, and specifically whether that's light or heavy hydrogen, we can start to get some kind of idea about how much water has been lost from Mars, and therefore how much might still be there today.
2021. Scientists at Caltech analyzed data from Mars's rovers and orbiters to discover the ratio of deuterium to hydrogen in the atmosphere. They find less of the heavy hydrogen than expected.
If Mars had lost a lot of its original water out into outer space, we'd expect to find lots of heavy hydrogen left behind in the atmosphere. But in fact, what we found was that the ratio told us that Mars didn't lose much of its water upwards, and so maybe the water went downwards.
Where is Mars's water hiding? Some scientists think it could be stashed away in the Martian rocks.
When we look at a rock, we often think this is a really dry thing. There's no water in there. But in fact, there's often a lot of water in rocks, and it's because it's bound up in minerals.
We're familiar with this process on our own planet. But here on Earth, that water is released when our rocks are recycled through plate tectonics.
On Earth, when we lock up water into minerals, then those rocks actually participate in the rock cycle, which means that they're going to be buried by all the active tectonics happening on Earth. And they get transported into the mantle where they get heated up. The water is liberated from the mineral structure, and it gets sent up, usually through volcanism, back up into the atmosphere.
Mars doesn't have plate tectonics, so there's no easy way to free the water. But this trapped water in the Martian crust could potentially provide a good water source for future human missions to the planet.
If all that water is still there, this might give us a lot more opportunities for the future exploration of Mars. Having a lot of water trapped in the Martian crust could be useful for the first human habitats and colonies to use that water on the Martian surface.
Changes in the crust can drive these minerals to suck up huge volumes of water, equivalent to a global layer over 300 feet deep. Researchers estimate that as much as 99% of Mars's water could be locked away below the surface. And Mars hides water in other ways too. Enter the European Space Agency's orbiter, Mars Express. Probing 1 mile beneath the Martian South Pole, it finds a secret store of water.
Really excitingly, we've discovered a system of lakes beneath the Martian polar ice cap. Lakes of what appears to be liquid water.
Now, these lakes are not very deep. They're probably only a couple of feet deep, maybe in some places even a couple of inches deep, but they're quite large. Some of these are about 20 miles across. And there's even some suggestion that these are connected with channels, kind of a system of very shallow Great Lakes near the South Pole of Mars.
The Martian poles are the coldest regions on the planet. Temperatures can reach 200 degrees below zero.
So why is it that underneath this cold ice you might even find liquid water? Well, remember you're actually going down closer into the interior of Mars there, and so that's warm. It's possible that the geologic activity inside Mars is warming the ice from the underneath.
But heat from the interior of Mars wouldn't be enough to keep these lakes liquid. The secret ingredient may be salt.
If you've ever spread salt on an icy driveway, you'll notice that where the salt hits the driveway, the ice begins to melt. Salt water actually freezes at a much lower temperature than water that's fresh. So if it's salty water, it could actually stay liquid at lower temperatures.
We still aren't 100% sure that the lakes are completely liquid. Some scientists think they could be lakes of frozen clay. Until we have a rover that can explore beneath the poles, we won't know for sure.
The only real way we can tell for sure is to send some kind of mission that drills right down through that polar ice and samples what we find at the bottom.